Namaskar, welcome to the CTET Mathematics Master Class. So today we are going to talk about LCM and HCF. So the sessions are organized by the Andaman Nicobar Island Education Department, and I am Manohar H, Senior Research Fellow, Department of Education, RI Mysore. So in this session we are going to talk about LCM and HCF, which is the most important topic for the CTET aspirants, which are mainly asking maximum 2 to 3 questions from this chapter. So there are series of questions and concepts are there. Sessions will be discussing, and coming to the today's first session, so we'll be talking about multiples and prime factorization and factors, and what is the HCF and what is the LCM. Okay, so before we try to understand the concept of LCM and HCF, we must also understand the concept of what multiples actually, and what is the prime factorization. So what are the factors, how we can identify the factors, how multiples are formed. So what is the highest common factor of given any number, and what is the least common multiple of given any number. So these are the basic things which we need to understand when we are trying to solve the LCM and HCF concepts. So the session will be going like this. We discuss the concepts related to LCM and HCF, and along with the concept we also try to look at the some of the previous questions, and we see in different ways how these problems can be solved in the regular classroom, how we solve, and also what are the tricks are available in order to solve these kind of questions. And it is mainly focused on exam oriented problem solving, which is useful for both the paper 1 paper 2 of CTET aspirants. Okay, so coming to the next slide. So now let us see what is the concept of multiples. So it is a number which is multiplied by the any natural numbers. So for example, if you look at here 7, 14, 21, 28, 35, what we can identify from this, what we can observe from this, what pattern can we observe from these multiples. So if you see the numbers of 7, 41, 21, 28, 35, we can see that these numbers are multiples of the one number. What is that? The number that's 7. So we can see that 7 is the multiple of 1. 14 is the multiple of 7 2 is the 14, 7 3 is the 21, and 28 is the multiple of 7 4 is the 28, and 35 is the multiple of 7 5 is the 35, which is these are all the multiple of the 35. Okay, so that means even we can remember the tables. Okay, so tables are found based on the concepts of the multiples here. Okay, so similarly, so let us see. Okay, obtained by multiplying number with the natural numbers, that is the basic meaning of the multiple. And for example, here we have discussed multiple of 5, so that means we have to try to remember the multiples of tables of the 5. So 5 1s are 5, 5 2s are 10, 5 3s are 15, 5 4s are 20. Like similarly, we have the infinity of multiples. It doesn't end at the one number because we have the numbers 0 to infinity. Okay, so now if you see, observe the 5 multiples, 5, 10, 15, 20, 25. So there is a one pattern which is involved in the 5. Okay, the first digit which is ending with only 5 0 5 0. So till infinity it will be ending in the 5 multiple of with the 5 1 10 0 and 5 0. Okay, so now, so these are some of the concept of multiples we have to remember before we solving the LCM and HCF. Okay, so there are some of the facts which we need to remember when you're trying to apply the concept of the multiples. That is, the multiples are infinitive, where it doesn't end at the 1. So always the multiple is greater than or equal to that number. Let us take 5 multiples, whether it is a greater than of that number and it is equal to that number. Similarly, if you see here 7, 14, 21, 28, 35, these are the equal to of that number 7 and greater than the 7. Okay, and these are the numbers are generated by the multiplication of that number. Okay, and then one more thing, second concept is prime factorization. How do you identify the prime factorization? Now let us take the example of 48. Okay, so 48 can be written as 2 into 24. And 24 again you can write as 2 into 12, and 12 can be again written as 2 into 6, and C again it can be written as 2 into 3. Okay, so now if you take it divisors here 2, 2, 3, so these are the 2 to the becomes 2 to the power of 4 and 3 to the power of 1. Okay, so here means 2 and 3 are both are the 2 to the power of and 3 to the power are the prime factorization of the given number. Okay, so now we also need to understand factors. How do you identify the factors? Now suppose let us take the example of the 24. Okay, now what are the factors of the 24? 24 can be written as 1 into 24, we can write it, and we can also write it 2 into 12, and we can also write 3 into 8, we can also write 4 into 6. Okay, so these are the multiples of factors of the 24. Okay, then there is another concept which we have to discuss. Suppose there are some of the questions where they are asking in based on this application. If there is a in order to identify like how many factors of can be identified in a given for the given number. So if n is equal to p to the power of a, q to the power of v, and into r to the power of c, the number of factors can be identified by applying this formula. So that means power of, when you see the p to the power of a, q to the power of b, r to the power of c, and p to the power of a, the power of p to the power of a is a plus 1 and b plus 1, c plus 1. If by applying this formula, we can identify how many number of factors can be formed by the given number. Okay, so for example, let us see 60. Okay, so now they are given for the 60 2 to the power of 2, 3 to the power of 1, 5 to the power of 1. Okay, so how many factors can be can be there for the 60? Now what is the here p to the power of a? 2. Okay, so 2 plus 1, 1 plus 1, 5 plus 1, 5 to the power of 1, 1 plus 1. Okay, so if you add these all 2 plus 1, okay, 3, and 3 into 2 and 2, so total will get the 12. So that means for any 60 numbers there are 12 factors are there. Okay, so now next concept, this is our discuss. Okay, LCM. So what is the meaning of this LCM? It is a least common multiple. Okay, so that means what is the meaning? So suppose in the CTET exams, how they ask, they will give the two numbers and they ask you to identify the what is the least common multiple of the given numbers in the both paper 1, paper 2. Now suppose for example, let us take multiple of the 3. So what are the multiple of the 3? So now remember the concept of the multiple. Okay, so 3, 6, 9, 12, 15 and so on, keep on numbers will be there. Okay, so these are the multiples of the 3. Okay, similarly for multiple of the 5, let us take multiple of 5, 5 1s are 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25, okay, 5 9s are 45, so like that. Okay, so now out of this 3 and 5 number, what is the least common multiple we need to identify? So now multiple of 3 and multiple of the 5 common numbers are 15, 30, 45. Okay, in out of these three numbers, which is the least common multiple of 3, 5, 15 is the first one, which is the common multiple between the 3 and 5. So this is the one of the way to identify the least common multiple of any given two numbers. Okay, then you have to remember one thing always. So LCM is the smallest number that is divisible by all the given numbers. So that means 15, if you do, let us take for in this case 15. Okay, so it is divisible by the given numbers of those numbers. Okay, so and there are other two ways where we need to in order to identify the least common multiple. So the method one is methods to find the LCM is a prime factorization. This is the one method where we find the LCM by using the this method. Okay, and another method is division method. So when you see the prime factorization method, so for example they have given like identify the LCM for the given number 240 and 924. Okay, so 240 can be written as in this way. You can see that 2 into 120 and 120 again you can be written as 2 into 60, and again 60 can be written as 2 into 30, and 30 can be again written as 2 into 15. 3 and 15 can be written as 3 into 5, and 5 can be written as 5 into 1. Okay, similarly for the 924 we can see that, okay, 924 can be written as 2 into 462, and 462 again we can write as 2 into 231. 231 can be again written as 3 into 77, and 77 can be again written as 7 into 11, and 11 can be written as 1 into 7. So this is the divisible, divisible by the these numbers. Okay, now if you see here LCM, how many divisors are there here? There are 4 times the number is divisible. So that means we can say 2 to the power of 4, 3 to the power of 1, and 5 to the power of 1. So in this number again we can see that 7 to the power of 1, 11 to the power of 1. Okay, so now what is the prime LCM of the total of these two numbers, we can say that 2 to the power of 4, 3 to the power of 1, 5 to the power of 1, 7 to the power of 1, 11. Total we'll get this much 18,480. Okay, so this is the one way of finding any two numbers of the prime factorization. So we have to see only which is a common of these things. Okay, and then method 2, division method. So for example, they are given like identify the least common LCM of the given numbers. So there are given numbers like 12, 15, 20 and 25. So now by division method we can do like that. So where 2 to the power 2 into 6, 12 and 15 which we cannot divisible 2, so we can take it as a common as it is, and then 2 10 is a 20, and then 25 cannot be divisible by the 2, so therefore we take it as the same. And then again 6, 15, 10, 25, you can see with the 6 can be divisible by the 2, 2 with the 2. So 2 3 is 6 and 15, 2 5 is 10, and then 25 cannot be divisible, we will take it the 7. Then we see the next number which we can try to divisible. Okay, now we can divisible with the 3. 3 1s are 3, 3 5s are 15, and 3 5 cannot be divisible with the 3, so therefore we will take it as it is, and 25 we cannot, so that we will take it as it is. Okay, then so you have to do the division, we have to follow the division methods till we get the remainder 1. So now we get the LCM is equal to product of all the divisors. Now what are the divisors? These are all the divisors of the given these numbers. Okay, so now if you see that 2 into 2 into 3 into 5 into 5, these are the divisors of the given numbers of. Okay, so if you multiply these things, you will get the 3. And this is the one way of identifying the least common multiple by the division method. Okay, so based on these concepts, some of the questions they will be asking. Okay, so now for example, they are given like one of the real application like Monica, Veronica and Razat, where they 24 seconds, 36 seconds, 45 seconds. Okay, after how many seconds will they meet again at the starting point? Okay, so that means we need to identify LCM of 24, 36, 45. So when you identify the LCM of 24, 36, 45, we'll get the 360 seconds. We can identify the LCM by using the either by division method or factorization method by saying like that. Okay, whatever we have discussed as of now, like that. Okay. So then HCF. Okay, so this is one of the important thing, highest common factor. So now LCM we talking about the least common multiple, but HCM is the highest common factor. So now let us take for example factors of the 9, factors of the 18, and okay. So when you see the factors of 9 can be written as 1 into 9, and 9 can be written as 3 into 3. Okay. Similarly, 18 it can be written as 1 into 18, 2 into 9. And 3 into 6 or 6 into 3. Okay, so these are, so out of these factors 1 3 9, 1 2 3 6 9, what are the common factors here? So we can see that 1 3 9, and the factors of 9 we have the 1 3 9, and the factors of 18 we have 1 3 9. These are the common factors of given two numbers between the 9 and 8. Okay, now what is the highest common factor? So in this again 139, if you see the 9 is the highest number, which is the highest common factor of given these two numbers. So again this also we have the two methods to identify the common highest common factor. Method one is same prime factorization method, and another is the equal division method, where we discuss in the LCM also like that. Okay, so now for 91, you have to identify the factors of the 91. 7 into 13 is the one of the factors of the 91, and 112 is the 2 to the power of 4 into 7. This is one of the factor, and 49 is the 7 to 7. These are the factors of the 11. So by out of these, or what is the common factor? 7 is the common factor. Okay, so this is the one way of identifying the highest common factor in when we are trying to solve the problems of the highest common factors. Okay, so now there are some of the things which we need to discuss, like there is one problem like where they are giving based on this concept, greatest measuring rod problem. Okay, so there are different rods they are given. One is the 7 meter, another one is a 3 meter 85 centimeters, another one is the 12 meter 95 centimeter. So now what is the greatest length of the rod that can measure each length exactly? So that means when maximum of number we need to identify. Okay, so then in this case what we do, we need to identify the we need to apply the concept of the highest common factor which we need to identify. So now when you convert this into meters, it becomes the 700 centimeters, 385 centimeters, 1295 centimeters. Okay, so now common you take off, apply the HCF of both all the three numbers, 700, 385, 1295. So then we'll get the 35 centimeters. Okay, so now there are some of the tricks where we can apply when you're trying to solve LCM and HCF concepts. The LCM is take highest powers of all the prime factors, and for HCF when you want to apply the concept of HCF, take only common prime factors which is the lowest of powers. Okay, and then this you will be applying in the next when you're trying to solve the problem. So the multiples always infinite in the number, and the factors also infinite in the number, and then perfect numbers 6, 28, 4, 96, 7 is these are the some of the perfect numbers. They also see that how whether it is a perfect number or not. Okay, so these are the things, and the special formulas which we need to identify when we're trying to solve this problem. One is that LCM of fractions. So when the question is given in the form of fraction, they ask you to identify what is the LCM of the fraction. Okay, so for that we need to identify by applying this formula LCM of numerator and HCF of the denominator. And when they ask you to identify HCF of the given fractions, where they will give the two fractions in the form of they will give the two numbers in the form of fractions, they ask you to identify the HCF of the fraction. So for that we need to remember the formula of HCF of the numerator and LCM of the denominator. So that means we need to identify first HCF of the numerators and LCM of the denominators. When we divide both, and then we'll get the HCF of the fractions. Similarly for the LCM of the fractions, okay, we need to identify first LCM of the numerator and then HCM of the denominator. So when you divide both, we'll get it a LCM of the fractions. Okay, so when again they also give some of the questions based on the decimals. Okay, convert the decimals into fractions, then apply the rules. So what we need to, when you give the decimals in some of the questions where they give decimals in the form of decimals, and then ask you to identify what is the LCM and HCF. So in such a cases, how we have to perform. Okay, so the fractions we need to convert into decimals we need to convert into fractions. So when you convert the fraction, then we can apply the same above formula in order to identify the LCM and HCF. And there are some of the questions where they discuss based on the relations between the LCM and HCF. So in such a cases, what we have to, for any two numbers AB, when they ask you to identify the relation between the LCM and HCF. Okay, so for that we have to do, okay, for two numbers, so 6 into B is equal to, like, for LCM into HCF. Okay, so for example, HCF they given, LCM they again. So what is the number we need to identify? So this in the second session we will be discussing. Okay, and then coming to the problem one, the previous questions where they are given. So they ask you to identify whether the given numbers are perfect numbers or not. Okay, so let us look at the option 1. 9 is a perfect number. So how to identify whether 9 is a perfect number or? So what we need to do, we need to do the factors of 9. We need to identify first. What are the factors of 9? 1 and 3 are the factors of 9 excluding the 9. Okay, so 9 we can write 1 into 9. And 9 again we can write 3 into 3. So 1 and 3 are the factors of the 9. And similarly, now what we need to do, so whether this sum, okay, factors of the sum, whether it is equal to 9, 1 plus 3, 4, 4 is equal to 9. Is it equal? No, this is not the equal. So therefore it is not a perfect square. Now question 2 is 6 is a perfect number, factors of 6. So what are the factors of 6? So 1, 2, 3 are the factors of the 6. Okay, so now when you add these all factors, 1 plus 2 plus 3 will get the 6. Okay, so 6 equal to 6, so therefore we can say that it is a perfect number. And similarly, is 13 is a perfect number? We can how we will check that? Okay, so now for that we need to identify what are the factors of 13. Okay, so factors of 13 we need to identify. So factors of 13 we can identify only, we can write it as a 1 into 13, which is not divisible with any other number. So therefore only factor of 13 is the 1. So 1 does not equal to 13, therefore we say that it is not a perfect number. So which is the only option is correct here? Only 2, option 2 is the correct option, where only factors of 6 are the satisfying in the given condition. Okay, so now always list factors excluding number and check the sum. So then we can say that whether a given number, whether it is a perfect number or not. Okay, so then this is a rule which they are applying. So now let us see, okay, the rule. Okay, what is the core formula of, for example, let us take the examples of find LCM and HCF of 12 and 18. Okay, so now we need to identify the LCM and HCF of the 12 and 18. So for example, LCM of 12 and HCF of the HCF of the 12 and 18. Now when you see that, okay, HCF, try to identify what are the factors of the 12. Okay, so 12 can be 2 to the power of 2 into 3, and 18 can be 2 into 3 to the power of 2. Okay, so when you see here, so HCF means we need to remember that lowest powers. Okay, so what are the lowest powers of from this number? We can say that 2 to the power of 1, and 2 is nothing but 2 to the power of 1, 3 is nothing but 3 to the power of 1. Okay, so these are the one thing. Okay, so now HCF is 2 into 3, that becomes a 6. Now LCM means least common multiple. So that means in a short method we can remember that highest powers of the given numbers. Now in the 12 and 18, what are the highest powers? So one is the 2 to the power of 2 and 3 to the power of 2. Okay, 3 to the power of 2. So now when you multiply both 2 to the power of 2 and 3 to the power of, you will get the 36. This is the least common multiple of the given number 12 and 18. Okay, so now you need to identify LCM, okay, divided by HCF. So when you get that, what is the obtained LCM is 36. What is the HCF? You got it here 6. Okay, when you divide, we will get the 6. Okay, so this is the rule where they apply in order to identify the LCM and HCF. So the core formula is the LCM of any given set of number is always exactly divisible by their HCF. Okay, so that is what we are discussing. So the LCM of any given set of numbers, 12, like for example, which we take the 12 and 18. Okay, it is always again exactly divisible by their HCF. Okay, so this is the LCM which you identify and HCF we identify. Okay, this number is always divisible by this number. Okay, so that is what the rule which they operate. So LCM of any A, B, C of, that means any number, okay, divided by HCF, again it will become a whole number. Okay, so remember always LCM is a multiple of HCF. Okay, HCM is always small number, LCM is a big number. So therefore HCF is always, it is in the LCM, multiple of the LCM. Okay, now there is another question. Let us say like this. Okay, the LCM of two prime numbers x and y is 161. If x greater than y, then the value of 3y minus x is. Okay, so now try to see that what they're trying to ask. Okay, by seeing the options itself we can say that. Okay, so the given LCM of two prime numbers x and y, which we don't know that what are the two numbers x and y, we need to identify that. So but okay, that two prime numbers of x and y is a 161. Okay, if x is greater than y, then what is the value of 3y minus x is. How do you identify this? And given options are the first option is the 2, second option is the -2, and third option is the 16, and fourth option is the 44. Okay, so now let us see what is the concept which is involved in the first. Okay, now use the property of the prime numbers. Okay, so now the 161, it is the what is the value, prime numbers we need to identify for the 161. Okay, so now for do distinct prime numbers, let us assume that x and y. Okay, now given x into y is equal to 161, that is the LCM of two prime numbers. We need to identify these are the two prime numbers. What are those two prime numbers? So when you do the prime factorization, apply the formula of the prime factorization of 161, we will get the 161 can be written as 7 into 23. Okay, so now here both the 7 and 23 are the prime numbers, which cannot be divisible by the any other number. It is divisible by the number itself. Okay, and then so that means what is the condition we got it, the multiple of factors of 161 is 7 and 23. Okay, now what is the condition here given? If x greater than y, so that means obtained factors of 7 and 23, which is the greatest number 23. So 23 becomes a x. Okay, then x, and 7 becomes a y. Okay, x and y. So now when since x is greater than y, take x is equal to 23 and y is equal to 7. Now you calculate, apply the what we need to identify finally, the value of the 3y minus x is. So now when you apply 3 y value in the given value, 3y minus x. Okay, so 3 into 7 minus x. What is the x value here? 23. 3 is 21. 21 minus 23. So that becomes a -2. Option 2 is the correct answer. Okay, so you don't need to do this much also. When you get the x value, then by seeing the options itself we can identify that. Okay, so for any two distinct prime numbers, LCM is the product of LCM is the product. Okay, so always factorize and use the x greater than is very carefully when applying this concept. Okay, and then there is another question which they are given. If x is equal to 2 to the power of 5 and 3 to the power of 2 and 5 to the power of 3, and y is equal to 2 to the power of 4 and 3 to the power of 3 and 5 to the power of 2, and z is equal to 2 to the power of 3 and 3 to the power of 3 and 5 to the power of 2, then find the LCM of x, y and z and find the HCF x, y, z, isn't it? So where we discuss in the first second slide formula. Okay, so that concept we need to apply here. Okay, so for LCM take, always remember that for LCM you take the highest powers and for HCF take the lowest powers. Okay, so now, so this is the question where they given if x is equal to this is the value and if y is equal to this is the value, if z is equal to this is the value, then we need to identify what is the LCM of x, y, z and HCF x, y, z. So this is also we can just by seeing the options, numbers itself we can identify. We can observe the pattern, what pattern exactly it is involved in this problem, and we can identify the given options. 130, 2 is the 45, 33 is the option 3 is the 60, option 4 is the 120. Let us try to see how we can solve this problem. Okay, so there are different ways we can solve, and one method is prime factorization method. Using the prime factorization to LCM and HCF numbers with the exponents. Okay, now what is the value they have given? X is equal to 2 to the power of 5, 3 to the power of 2 and 5 to the power of 3, and y is equal to 2 to the power of 4 and 3 to the power of 3 and 5 to the power of 2, and z is equal to 2 to the power of 3, 3 to the power of 3 and 5 to the power of 2. Now if you see this all the number primes, okay, 2, 3, 5 in the x and 2, 3, 5 in the y, z, 2, 3, 5 which are the common primes of the in a given problem. Okay, then what is the powers they are given? Okay, 2 for the 2 to the power of 5 highest power. What is the highest power they are given? 2 to the power of 5, 2 to the power of 3, 2 to the power of 3. Out of this, what is the highest of 2 to the power of 5? In the similarly 3, which is the highest power here? 3 to the power of 2 or 3 to the power of 3 or 3 to the power of 3. 3 to the power of 3 is the highest power. Okay, and if you see in the 5 prime, okay, so 5 to the power of 3, 2 and 2, so which is the highest one? 5 to the power of 3. Okay, so now for LCM, when you try to identify the LCM, we need to take the highest two powers. Okay, so now what is the here LCM of the given numbers? 2 to the power of 5, 3 to the power of 3 and 5 to the power of 3. Okay, for HCF, the only common prime basis is the lowest one. So when you have the bases of the common, similarly for like 8, 2, 3, 5, 2, 3, 5, 2, 3, 5. These are the bases of the common. Okay, for highest for HCF we need to take the lowest powers we need to take. So what are the lowest powers in the given question? 2 to the power of 4, 2 to the power of 4, 2 to the power of 5, 2 to the power of 4, 2 to the power of, so this is the lowest one, 2 to the power of 3. In the 3 prime, 3 to the power of 2, 3 to the power of 3, 3 to the power of, so 3 to the power of 2 is the lowest one. In out of the even 5, if you see 5 to the power of 3 and 5 to the power of 2 and 5 to the power of 2, 5 to the 2 is the lowest from here. So when you multiply this, we will get the HCF, 2 to the power of 3 into 3 to the power of 2, 5 to the power of 2. Okay, so we need to remember only one thing. LCM means always you take the highest powers of all the prime factors, and HCF means you take the lowest powers of the common prime factors. Okay, now the same question only. So now how they're trying, how we are trying to solve this one, let us see that. Okay, now we got the LCM, okay, by through calculating. LCM is 2 to the power of 5 and 3 to the power of 3, 5 to the power of 3, and HCF we got it this much. Now we need to provide the required ratio. We need to identify the LCM of XYZ and HCF XYZ. Now we got the powers here. Okay, LCM is the this much and HCF is the this much, 2 to the power of 3, 3 to the power of 5 to the power of 2. Now we can apply the concept of exponents, because if you see the base, all the bases are the similar. Okay, only exponents are the changing here. So therefore we can apply a to the power of m by a to the power of n is equal to a to the power of m minus. So that means for each and every prime here, we are trying to write in the form of a to the power of m minus n. Okay, so now 2, if you see 2 to the power of 5 and 2 to the power of 3, so this can be written as, well, let us take it a to the power of m and by a to the power of n. Okay, a to the power of m minus n. So here m is the 5 and n is the 3, so that 5 minus 3. Similarly for the 3, this is the m, this is the n, 3 minus 2, and similarly for the 5, 3 minus 2, this is the m and this is the n. So now when you simplify this one, we'll get 2 to the power of 2, 3 to the power of 1, 5 to the power of 1. So now if you calculate this value, 2 to the power of 2 can become a 4, and this is a 3, this is the 5 to the power 1 is nothing but 5. Okay, so when you multiply this, we'll get the 60. Okay, this is a 1, so the way of solving the problem. Okay, prime factorization of each number. Okay, so this is also same we applied in that. HCF, for LCM we are taking the highest powers, and HCF we are taking the lowest powers. Okay, so now option 3 is the correct answer. So this is a one way of applying and solving the problem when you give this kind of a question. LCM, when they give different values, and when they give base the same and powers are different, and when they ask you to apply LCM of XYZ and HCF, LCM and HCF. Okay, so this is the one way of solving the problem. Okay, now there is another question which they are given. Sum of HCF and LCM of 420 and 28 is, okay. So what is the option, whether it is a 140, 144, 754 and 136, okay. So what we need to identify here, we need to identify highest common factor of the given numbers. What are the given numbers here? 4, 20 and 28. And what is the least common multiple? LCM, we need to identify the LCM. We need to identify LCM of odd numbers, 4, 20 and 28, okay. So now let us see how to solve this problem, okay. So for first we can see that, okay, so HCF cannot be larger than the smallest. This is a fact which we need to understand, okay. So HCF cannot be larger than the smallest difference between the numbers. Now in the given question they are asking us to find out the HCF and LCM. So HCF are what the numbers? 4, 20 and 28. Now in order to get the for HCF, let us see the difference between the 4 and 20. Now there are three values they are given, 4, 20 and 28. Now take the difference of 4 and 20 and take the difference of 28 and 28. So when you take the difference of 4 and 20, we will get the 16, and when you take the difference of 20 and 28, we will get the difference is 8, okay. So now the HCF must be factor of these differences. What is the difference? We get the 16 and 18. So now HCF should be always factors of these differences only. Now let us try to see the factors of 16. So that means we are trying to simplify the problem here, okay. So now factors of 8, okay. Now for factors of 8 we can write 1 into 16, and we can write 2 into 8, and we can write 2 into 8, and then we can write 16 4 into 4, like that, okay. So these are the factors of 16, 1, 2, 4, 8, 16, and factors of 8 also 1 into 8, 2 into 4, 1, 2, 4. These are the factors. So now out of these we have to identify what is the common factor here. So what is the common factor? 1, 2, 4, 8, which is 4 is the in this also what is the common factor? 4. This is the highest common factor of the given this 4 and 20, okay. So simply you can also observe that 4 divides 4, 20, 20 perfectly. So HCF is the highest common factor is the 4. That is also can be seen. Then LCM, okay. So one is that we need to identify the HCF and next in the LCM, okay. So when you take the LCM, take the largest number in the given numbers. Now what are the questions they are given? 4, 20, 28, okay. In these numbers, what is the largest number here? 28. Let us take the 28, okay. Now check the multiples of 20 until you find the divisible by both the 4 and the 20, okay. Now we are taking the 28 number here, and we are checking that whether it is 28 can be divisible by both the 4 and 20, okay, both the 4 and 20, okay. So that means a multiple of 28 we have to see, and with this multiple of 28 perfectly whether it is a divisible by 4 or divisible by 20. So both conditions should be satisfied, okay. Now multiple of 28 ones are 28, 28 twos are 56, 28 3 is a 84, and 28 4s are 112, and 24 so 28 4 5 is a 140, okay. So when you see the 140 here, okay, 28 can be divisible by 4 but cannot be divisible by the 20. Here also same, 56 can be divisible by the 4 but it cannot be divisible by the 20. Similarly 28 3 is 84, it can be divisible by 4 but it cannot be divisible by the 20. Similarly 112 it can be divisible by the 4 but it cannot be divisible by the 20, okay. So now if you see the 140 it will be divisible both divisible by 4 and divisible by the 20, okay. So now for multiple of 28 divisible by both 4 and 20 is the 140. So therefore LCM we can say that it is a 140. Or if you find difficult in this, we can also go back to the method where we use the factorization method, division method. By using that also we can try to identify the LCM, okay. So now what they're asking is we need to identify the what is the common factor sum of the HCF and LCM of the 4 and 20 and 28, okay. So now we got the HCF is the 4 and also we got the LCM of given numbers, that is a 140, okay. So now when you add the sum, both will get the 144. So option 2 is the correct answer for that, okay. So which is the correct answer? 144, okay. So these are the one of the questions where in the previous for paper 1 they are asking. So very basic questions where they're trying to we need to identify the sum of the apply the concept of HCF and the LCM and common multiple, and we need to identify that, okay. Even if you also do like this, identify the factors of 4 and identify the factors of 20 and identify the factors of 28, and then we can see the common factor, okay. So that is the one way of solving this problem, okay. Now there are some of the concepts, okay, where along with that they are asking like we need to they'll give a one question and we need to identify what is the number of the factors. Okay, if a number is expressed in the form of n is equal to a to the power of x into b to the power of 5, so we need to identify how many number of factors are there for that given number. So for that we can see that x plus 1 y plus 1 of formula. Similarly, if they give c to the power of something, that is equal to like z plus 1. So this is the formula where we can apply. For each prime factor, the exponent can take any value from 0 to its power, okay, including the multiply the number of choice for all the prime papers. So for example, like they are given, find the number of factors of 520. So what we need to identify here, number of factors of the 540 we need to identify. Now step 1, we'll see that prime factorization of 540. So when you perform the factorization method 540, so like when you divide through the prime factorization, so like that 2 2s are 4 and 2 7s like that. Okay, so when you see that, like we'll get the 2 to the power of 2 and 3 to the power of 3 and 5 to the power of 1. Okay, now we got it the factors of prime factors of the 540, and then we try to see the apply the formula. Okay, so what is the formula here? So when you try to identify the number of factors, 2 plus x plus 1 and y plus 1. Okay, so that means let us assume that this is the x, okay, this is the y, this is the z. Okay, now what is the value here? X, that means 2. Okay, x plus powers, okay, x, y, z. 2 plus 1, 3 plus 1, 1 plus 1. Okay, so now simplify this one. Okay, 2 plus 1 is 3 and 4 and 1 plus 1 is the 2. So when you multiply, we'll get the 24. Okay, so how many total number of factors of 540 is? There are 24 factors of can be identified for the number of for the factors of the 540. Okay, for any, so one thing we should remember always, okay, each exponent xyz gives exponent plus one choices. Okay, multiply all choice to get the total number of the factors. If you want to identify the total number of factors, okay, the whatever the exponent like xyz etc is given, for that we need to add only exponent plus 1. So this is one of the concept where repeatedly some of the questions are asking in the CTET exam preparation. Okay, and then there is another concept, so sum of the factors. Okay, now we previously discussed how many factors we can identify. In this again, one of the factor, based on that we need to identify sum of the factors. Okay, so that means we need to identify the factors and then we have to see the sum of the factors of that given numbers. If a number is expressed as n is equal to a to the power of x into b to the power of 5, then sum of all its positive factors are a to the power of x plus 1 minus 1 by a minus 1 and b to the power of 5 plus 1 minus 1 by b minus 1. Okay, so why actually it is work? So for any prime power a to the power of x, the sum of its factors is always 1 plus a to the power of 2 plus and so on plus a to the power of x, that becomes a to the power of x plus 1 minus 1 by a minus 1. For similarly for b to the power of 5, the sum is b to the power of 5 y plus 1 minus 1 and b by b minus 1. So multiply the sum of all the prime powers when you get this one. Okay, so for example, find the sum of all the factors of 248. This is the one question they asked in the previous questions. Okay, in the previous CTET. So now what is the factors of the 248? So again we can use the division method or factorization method, and we can identify the factors of 248 is 2 to the power of 3 and 31 power of 1. Okay, now in this, okay, so let us assume that this is the x is equal to 3, okay, and y and b is equal to 1. Okay, so we are trying to apply this in this formula. Okay, now 2 to the power of 3 plus 1 minus 1, what is the a value here? This is a 2. What is the b value here? 31. Okay, so a is equal to 12, b is equal to 31. Okay, so now 2 to the power of what is the x value here? This is the y value. Okay, so now 2 to the power of 3 plus 1 minus 1, y value is a 2 minus 1. Substitute these values into the given formula and then we'll try to simplify that, we'll get the answer. So 31 power of 1 plus 1 minus 1 by 31 minus 1. Okay, now calculate this one. If you calculate 2 to the power 3 plus 1, 2 to the power of 4 minus 1 by 1 into 31, 1 plus 1, 2, that means 31 power of 2 minus 1 and 31 minus 1, 30. Okay, so when you simplify this, 2 to the power of, we'll get the 16, 60 minus 1 by 1, and when you 31 square if you do, we'll get the 961 minus 1 by 961. So 961 minus 1 by 30. Okay, so now if you simplify this, 15 by 1 will get, so that means nothing but 15, and if you simplify this one again, we'll get it 960 by 30. Okay, so when you simplify this, we'll get the 15 into 30. So therefore when you multiply again this, simplify, we'll get the answer is the 428. So the sum of all the factors of 248 is the 480. So whenever, so whatever the factors we get it, okay. So when you sum thus all the factors, we get this much answer for this question. So these are the some of the questions where they in the paper 1, paper 2, mainly from the basic concepts, okay, applying where LCM and HCF concepts and trying to solve the problems. This different types of questions they're asking in the very frequently, okay. Now which you need to remember, okay, prime factorize and then plug into the formula, that means apply the formula and simplify, get the sum. So if you remember this formula, when they ask you to find the sum of all the factors, easily you can identify the sum of the factors of any given number, okay. So then, so this is what in the from the basic things they are asking in the both paper 1, paper 2, based on the concept of LCM and HCF, and by concept of multiple and prime factorization, how we can identify the LCM and HCF by using the prime factorization division method, okay. So these are the things which we have discussed in the session 1. So one is the what is the HCM of a to the power of 2, b to the 1, a to the power of 3, b to the power of 2. So how to find this, okay. So these are the things which we discuss. For each common prime base, take the lowest power, and common primes are the a and b, okay. So that means a to the square, b to the a to the power of 2, b to the power of 2. We have to take only the lowest powers for the HCF, okay. That is you must remember always, okay. And then is one is a prime number. A prime number has exactly two factors, 1 and itself. So 1 has the only one factor, which is the 1, okay. So therefore it is not a prime number. Where this is also they asked in the one of the CTET question, okay, whether 1 is a prime number in the given options they are given, okay. So are multiples finite or infinite, okay. Multiples of number obtained by the multiple itself are the natural numbers. So therefore there is no largest natural number, so it's or infinity, okay. So the multiples are finite, so that means it's infinity, there are no finite, okay. These are the basic things which we have discussed in the this session. And let us try to summarize what and all we have learned in this question, in this session, okay. So what we learned today, key previous questions we explored, and then key concepts, and then why it is matters we discuss, okay. So when you see the factors divide exactly 1, it is a factor of every number is a factor of itself, okay. So and then perfect number, sum of the factor including itself is equal to the number, then we say that it is a perfect number. And prime factorization method, highest powers of the LCM and lowest powers of the HCM, how we can identify the LCM and HCF. So for LCM we have to take the highest powers, and HCF we have to take the lowest powers, okay. And then some of the formulas which help identify the factors and some of the factors efficiently, which we discussed in the and we solved one problem in the last just 2 minutes back, okay. Then why it is matter, this concept, it builds a strong number sense and logical thinking. It helps you to develop your logical thinking, and if you remember all the these formulas, and it easily we can solve the problem, okay. So it helps to solve the faster with accuracy, and essential for these concepts, especially for the TET and CTET, okay. And then it is also foundation for the math concepts, which is like decimals and fractions, all those things, okay. Now and the concept base we have discussed in factors and perfect numbers, understand the factors and different way, and the idea of perfect numbers using simple divisor logic. And then we also discuss the primes and LCM of two primes. LCM of discipline prime is LCM of distinct primes is their product, and we use the prime factorization, how we can use the prime factorization very smartly. And LCM HCF with the exponents, and we use highest powers of LCM and lowest powers of HCF, okay. So then when you use the differences, the tricks for the HCM and LCF, use the differences multiply to find the HCF LCM quickly, which we have discussed one of the, okay. This is the session 1 objective, and further much more advanced LCM and HCF questions we'll discuss in the session 2. Thank you.